So, just very briefly before we start, Paul already said a few words, but I really want to start by saying you and presenting you very, very briefly what is the Society of Glass Technology, and invite you to scan this QR code, which will directly link you to the website of the SGT. So I will not read the text, it's not necessary. It's what is needed to say is that SGT is a community that is dedicated to the study of glass from the past, present and future. So it's not only focused on historical studies at all. It is also very strong in science and technology and industry and innovation, and the other two lectures will cover these topics as well. So, this being said, and starting with the presentation, I decided to talk a little bit about our work at VCART and the studies we have been developing on glass archaeometry. And the title is Glass Archaeometry, Intertwining Chemical Analysis, Historical Records and Production Techniques. So, and to start, I decided to go into the dictionary to revisit the definition of archaeometry. So, if we visit the Merriam-Webster dictionary, it says that archaeometry is the application of scientific methods and technology to archaeological studies. And in the definition by Springer, I will not read the entire text, it's not necessary. It's just to say that archaeometry, it's a synonym of archaeological science, and it's a formal field of study whose people apply techniques and approaches from physical, chemical, biological, and earth sciences and engineering to address archaeological questions and problems. So, we wonder, is archaeometry exhausted in chemical analysis applied to heritage, in this case glass? We don't think so. So at VCART we have been developing a methodology for archaeometric studies that encompasses a series of steps. We will go a little bit into detail into these steps, and we'll look into a case study to see how we apply the methodology. So we always start with the chronotypological analysis of the glass fragments, and we'll see what does this mean. The iconography, so understanding that shape in the context and chronology. Then we move into the chemical characterization, so the archaeometry per se, reproductions, both of the shapes and of the glass chemical composition, and finally, and I think it's most relevant, to transform this data into understandable information. So the question that we like to ask, and so what? So why should we care? So the chronotypological analysis of fragments is more or less a long process, very time consuming, that is basically to move from what we see here, so to move from fragments to shapes, to objects. So we need to understand what is the sets of fragments and shards we have, and to move into objects. Okay, this implies a solid knowledge on the shapes, on the decorative processes, to look into a fragment and understand what are we looking at. Then the iconography is, once we have a shape, that's why the chronotypological study is important. Once we have a shape, we need to look for that shape into representations of that time period. This allows us to create a context for the objects in the social fabric, to place them inside a house, in a religion, if they are part of rituals, and so on. So this is crucial. It's a crucial step for a deeper investigation about an object or about a set of fragments. So then we move into the chemical characterization. These are just some examples of the techniques we may use to apply on glass. So we really like to determine the chemical composition, and for that we can resort to X-ray fluorescence, to PIXI, which it's also based on X-rays, but it implies the existence of particle accelerator. LACPMS, so it's mass spectrometry, but we also like other techniques for other means. For instance, if we want to identify the chromophores or the presence of nanoparticles, determining the glass chemical composition may not be enough, so we need to resort to other techniques such as the UV absorbent spectroscopy. If we want to also look into particles but observe the glass morphology, we may use optical microscopy or scanning electron microscopy. And synchrotron radiation, where different techniques fit on, can help us, for instance, identify valencies or speciations of elements which may be fundamental to understand, for instance, a coloring process. So what do we determine? And before we move into this, I decided to put here an example of samples we have for glass, archaeological glass, just for those who are not familiarized with the size of the samples we use. They are really small, so we don't need a lot of samples, and sampling is fundamental because it allows us to travel with the samples and to use the same samples in different techniques, and with this we don't need to be moving the fragments or the objects, especially if they are fragile. So what do we obtain in the end? So what we determine are the elements that we then transform into oxides that basically fit in the matrix former, the flux of the glass, and its stabilizer. So these three main components will account for about 90% of the glass chemical composition. The remaining 10% will be divided into the coloring, decoloring, opacifying, fining agents, okay? And the rest into the trace elements that come attached with the raw materials. So once we have this, these are some of the questions we ask when looking to a glass chemical composition. What is coming attached to the silica? Okay, because those elements can help us tracing back the silica source. When we look into the flux, for instance, we will also be looking for trace elements to understand the origin of the raw material, and also if it was treated or not. For the stabilizer, the same question. Can we identify elements that help us understand the origin of the raw material? The whole composition together will help us understand the recipe that was used to produce that specific glass. So finally, when we look into the color, we want to understand if it's natural, a natural hue, or if it was colored on purpose, if it was discolored, and so on. And then we move to reproductions. For us at VCART, reproductions are fundamental, and we can do two different types of reproductions. So we can go from historical recipes and produce the glass itself, or we can look into a shape, study the shape and try to reproduce it, or both. We can use the historical glass to reproduce the historical shape, and this can bring a lot of information that, as we will see in a few slides when looking to the case study. So the case study that I would like you to present today, very briefly, because we won't have time to go into a lot of details, but it's a work that was developed by Anna Cristoforetti. She was my PhD student until last June when she finished her thesis, and she studied a set of or different sets of glasses, archaeological ones found in Portugal and dated between the 14th and 16th century. So Anna studied over 800 fragments. spread through the country, focused on the south of Portugal. So the first step Anna did was to transform the fragments into understandable objects, so the chronotypological study, which allowed us to divide the shapes into a chronological order. So this is very important to see differences in the taste, in the circulation of objects and shapes and decorative features as well. So within this very big work, I will show you a specific case study, which is the sprinkler, and why this shape. Because this shape, so far as we know, it was only found in Portugal. If I'm not mistaken, there we know one case in Spain. So we can say it's highly likely an Iberian shape. And so after identifying the shape, we then go to the books, to the representations of the shape. And this was very, very important, because for the first time we were able to find this shape represented in a feminine world related to the Portuguese and the Spanish crown. It was found before a representation in the Nativity of the Virgin. It was only one representation, and this came to consolidate the use of the object and its presence actually in the Portuguese and Spanish royalty strata. So this will solidify then the study that we will make. So after this, and I have a short video that I will put here while I'm speaking, then it was very important to do the reproduction of the shape, and for that we had the help of these two amazing ladies who were students of the Master of Glass and Ceramic Art and Science at VCART. And the idea is then, when we observe the shapes being formed, we can look into the movement of the glassmaker, see the types of tools that are being used, the steps we need to obtain this shape, and also to understand if this is a simple shape to obtain or something that implies a bit more mastery from the glassmaker. So this is a very short video of this. This was made from over 40 minutes of filming, so it's just a simplified version of the making of the shape. So when we analyzed the chemical composition of these objects, the sprinklers, first it is important to say that the majority of them were dated to the 16th century from the set. And I cannot go into detail concerning the chemical composition, but what Anna could find is that in terms of silica sources, these objects find no parallel outside Portugal. So we have this idea that glass made in Portugal may have an alumina, so aluminium oxide content, high and very high. So we are talking about contents above 4, 6, 7 weight %, which is a lot for historical material. And so far we have not been able to find other glasses with this amount of alumina outside the Portuguese territory. So looking to the flux, we see that there are some similarities with Venetian recipes. So some care was made in the selection of the fluxes, so the plants that were used to be the source of sodium, and the way these were treated. So these sprinklers that we see, a small image here on the slides, they are all colored in purple, which also implies strong control of the atmospheres in the furnace. So these were highly likely luxury objects that were used in the feminine world, and as far as we can say, they were probably locally produced. So when we look to the overall conclusions for not only for the sprinklers but from the set dated to the 14th and 16th century, all fragments that were analyzed, over 200, were all soda lime silica glass, and this prevents us from identifying trades with Northern and Central Europe. So we say that it was mostly a Mediterranean tradition. The shapes and types are mostly common with the European panorama, with some exceptions. The one that I just showed you is an example, the sprinklers. And Anna was able to identify 5 distinct compositional groups that then, relating with the making of the objects and the shapes, have other implications in the conclusions about the sets. And we can see here again another slide with images showing some conclusions. Is that we can say that most of the objects find no parallels outside, in terms of composition, find no parallels outside what has been found in Portugal, which keeps moving us to a place where we will probably able to say that we had a strong Portuguese glass production. So what? So the contributions to the history of glass is that from the 14th to the 17th century, and over the last 15 years, over 500 fragments have been studied in different PhD and master theses, and over 90% of these objects cannot find compositional parallels outside Portugal. And this new research-based glass history in Portugal is being written. So the ongoing study ultimately aims to safeguard this continuity of human creativity and skills, from the ancient craftsman that shaped molten glass, to the medieval artisan that mastered multi-layer enameling, for instance, and the contemporary communities whose intangible practices remain bound to material worlds. So across different epochs, our focus remains the same: to understand how knowledge moves, how materials shape meaning, how craft mediates identity, and how can we preserve these objects together with the embodied knowledge and the social worlds they carry. So parallel in future work, we are studying the raw materials based on historical sources, so collecting the raw materials and making tests with them. If we want to move forward the analysis of museum objects, we are dealing with complete unsamplable objects, so we need to revisit and fine-tune the analytical methodology, and with the final aim of achieving the intangible knowledge these objects contain. So I do not want to finish without showing you again our slides, and if you did not have the chance to scan the QR code, you can do it now. And our main objective with these talks is to entice you into becoming a member. The Society of Glass Technology needs all of us to keep being a reference in the advances on glass studies. And thank you so much for the presentation, for listening. So I don't know if you have any questions that you may want to ask. You can use the chat room. You can unmute yourself and ask.
I have lots of questions, but I'll give way to other colleagues before I ask. Okay, so no questions from other colleagues. Have you looked at the sort of parts per million trace analysis? What is that telling you?
So when we, mostly when we do the laser ablation mass spectrometry, so the LACPMS, we can go into that detail, which for us it's gold. That tells us a lot. So most of the times it's interesting because we are not looking for the overall composition. We are actually aiming for those parts per million and parts per billion elements, because those are actually the trackers that help us trace the origin most of the times of the silica source. That's what we are looking for, because it's a geological material that changes almost anything in the chronologies we study. So they do tell us a lot, and they are what help us try to identify the origin of the silica source. And what we have been seeing for glasses we believe are highly likely Portuguese production. Titania, it's very important. Alumina, although those are not in parts per billion. Hafnium, zirconium, so these are the elements that show different signatures and are helping us identify what is probably made, locally made. I'm only saying probably, highly likely, because we have no furnaces in Portugal. This is the problem. We have no furnaces, no glass-making centers, no glass-making furnaces excavated. So we lack this comparison. That's why we need to go around with all the other methodologies, to try to say it's locally made, national, a national product.
Well, I guess that nicely leads into my second question, which is, have you looked into whether there are any mining records or geological records? Because if you've got a fingerprint for the sand, then if you could find sources in Portugal that can provide sand with similar ratios of alumina, titanium, other contaminants, that might be a guide to which regions or areas or even which quarries the sand may have been originally excavated.
So we had a project that we hope to continue where we analyzed a set of sands from north center of Portugal, Coimbra, so from the Mondego River, because it is a region very, very rich in glass, dated to the 17th century. So all the excavations are very rich in glass from the 17th century. And the historical records point to a possibility that Mondego River was a local place where glassmakers would be collecting the sands. So we did analyze different sands, and 2 or 3 sands, I don't know the number from the top of my head, but 2 or 3 sands had the exact same signature that we find in a big number of glasses found in the same region. That was for us a very happy moment at Vicart, because for the first time we were actually able to see a local raw material that is almost for sure was used in the making of those glasses. Now we would like to continue with other sands from other locations, sands and pebbles, but also with the flux, because there is this idea that the barilla, Portuguese and Spanish barilla, give a very high amount of potassium in the glass, although it's a soda glass. but we don't have any studies to support that. So it would be, although plants suffer a lot with the industry and the pollution, so the chemical analysis will not be exactly the same as if we were collecting the plants 500 years ago, but still I think it's worth understanding the different species of Barilla we have, because it's there are many species, and if they, what are the contents of sodium and potassium and other elements they are giving to the batch.
Fantastic. Thank you, Inês.
Thank you so much. So if, I don't know if anyone has any other questions, comments, if you want to share experience.
Sorry, just let me turn my camera on. Hi. I might have missed it, but since you showed the QR code for SGT twice, is there a specific role that SGT played in the project you just presented, or is it not related?
So SGT is always present in our works because we always present. So SGT has this annual conference, which is very important to share the knowledge, and because of this connection with SGT, I was actually able to make a partnership with a colleague very famous in the studies of English glass, Colin Brain, and it was because of going to all the SGT meetings that we were actually studying glasses from Portugal, but also from Ireland, high in lead, and that contributed to these conclusions about what was being produced in Portugal, what was being actually imported from abroad. So it played this very important role of creating a community where we can share and where we can actually meet the colleagues that are experts on other subjects and with whom we can collaborate.
Thank you.
Thank you. So if no one has any other questions, or if you don't have anything to share, let me just remind you that on the 12th and on the 19th of December, we'll have 2 more talks. Just stay tuned because we will be sharing the content